Okay, so here we have Arduino 4, the controlled blink, whereas our basic goal is to create a function that, I guess, operates the LED on the Arduino board, which is going to be pin 13, as you can see here. We define the integer LED pin equals 13, so that'll go to the light already pre-installed on the board. We have our setup. We're saying that pin 13 is gonna give us an output, or that we are outputting to pin 13 throughout the program. And then our loop is going to be, we define the on time and the off time, and we can just use the plain old integer with that because it's only values of 100 and 300, and we can change those values very easily going before they run through the blink program or function that we are about to go over. And so here's the blink function. Again, we have to define the integers for the on time and the off time, and that we called up here. And then we also have to define the start time is 0. This is really important, so static means that you'll only find the variable inside of this function, and then long gives us up to a value of 2,147,000,000 yada 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 milliseconds. So this is going throughout the program. As you'll see, this number is going to get bigger and bigger and bigger, and if you just did integer or int, you'd only get up to 32,767 milliseconds of storage on there, or the value go up to that amount. So I don't believe we need to define that here, actually, because we defined it earlier. And we have if, so we're going to go through the logic of the light being on or off, and if digital read of the LED pin is equal to 1, that means that the light is on. And then we go on to say if millis, which is pretty much the running clock of the program, is minus the start time, which first run through is going to be 0, is greater than the on time value, then the start time is going to then be defined as the current time in the program, and then we are going to change with digital write the pin to low voltage, which would mean it is off. Then next part is if it, and we're comparing to the digital read of the LED pin being on. If the LED pin is off, then the time minus the start time, if that is greater than the off time that we defined, then the program moves forward, and the start time is then the current time that is the program is at, and then we digital write the LED pin to high, which it turns the light on. And here we have the running program. Well, we made one quick change, make sure that everything is defined and uploaded, and as you can see here, pin 13 is going on very brief flash and then a little bit longer off period. And if we wanted to change any values, let's just say we wanted the on time to be 1 second, off time to be 3 seconds. Upload. We're currently on the off period, on for a second, off for 3 seconds. So, and it took me a while to figure out, but the program would work for about 32 seconds, or just over 30 seconds, and then it would not work because, or just have a very dim light because it didn't know what to do, and it couldn't store any more data for the start time. So the whole program got confused, but now this can go on for over 2 billion milliseconds, which is 2 million seconds. So very, very important switch